Okay, so we're going to do half of 1.5 today. Um, Big thing here, you talked about this in Algebra 2, but domain and range. This is a very important concept. You talked about it in Algebra 2, but we are going to talk about it all year in pre-calculus. This is something that I expect you to be able to look at a function and be a function's graph for right now. We're going to talk about graphs and what their domain and range would be. Eventually, we'll be able to look at just a function and be able to tell the domain and range. Okay. Um, so domain. Okay, I have here the set of all real numbers for which an algebraic expression is defined, described to be input or the independent variable. Okay, let's put that into terms that make more sense to you. What variable are we talking about? Okay, we're talking about x. Okay, so if we are looking at a graph, we are talking about where do we have x values on our graph. Okay. X, when we talk about a function, y equals 2x plus 3, x is the independent variable. That's what we're plugging numbers into. When we plug values in for x, we get y values, which is why our y value is called the output, okay, or the dependent variable. Our y is depending on the numbers we plug in for x. So our range is all of those y values that make sense in our graph or our function. Okay? So really, I mean, don't feel like you ever have to write everything word for word, what I have up here. If you want to paraphrase, that's fine. Okay, or if you choose not to write something down, you can decide how you want to take notes, but don't ever feel like you have to write everything word for word. If you want to, that's fine. Okay? The big thing, domain, what x's do we have? Range, what y's are we working with? Okay? You've done domain and range before. What we're going to do is we're going to change the notation a little bit. Okay? So we're going to be working with a new notation. Let's look at this graph. Okay? First of all, I want you to notice that this is a closed circle. This is an open circle. So that's going to affect how we notate things. Okay, so first of all, let's talk about our domain. Okay, so we're talking about our x values. First of all, does this function go on forever? No, it's only a piece of it, right? So where do our x values begin? Where do our x values begin? -1. Okay. Does it include -1? Yes, because we have this closed circle here, right? Where do my x values stop? At 5. Does it include 5? No, because we have that open circle there. So we would say that our domain x is greater than or equal to -1, but less than 5. All right. What about our range? Where do our y values begin? Our y values, here's our y-axis. Our lowest y value is here at -3, isn't it? Does it include -3? Yes. Where do our y values stop? 3. Does it include 3? Yes. Okay. So is everyone okay with my notation? All right, we all agree there. We are not going to use this notation anymore. Okay? I'm going to teach you a new notation. All right? It'll take up less room. All right? And I expect you to use this notation from here on out. Okay? We're going to use parentheses or brackets. Brackets are going to take the place of like a greater than or equal to. Okay, a bracket means we're including that number. A parentheses means we are not including that number. Okay, so I always think, a parentheses is kind of like part of an open circle. if that's a way for you to remember that that is not including, okay? Because you kind of associate that with, you know, the open circle, okay? Brackets, we're framing it, okay, we're going to include that number. All right, so now we're going to rewrite our domain and range. Okay, our domain goes from -1 to 5, correct? So I'm going to write, this is going to be kind of like, it's going to look like an ordered pair, but it is not an ordered pair. So we're going to begin at -1 and we're going to continue until 5. -1 was included, 5 is not included. So our domain is from -1 to 5, including -1, but not including 5. Okay, our range is from -3 to 3, and it includes both endpoints. Everyone okay with that notation? Okay. Here's an easy one, finding zeros. Okay, what do I mean by zero? What's a zero of a function? Which intercept? Okay, anytime I say 0, we're talking about the x-intercept. Where is y equal to 0? Okay, so when I say finding zeros, we're talking about where our function is 0. So all we have to do is set our function equal to 0. I know this is a tough one, guys. What are our zeros? What are our zeros? Come on. 0 and 7. How did you get that? Okay. Zero product property. We have a product that equals 0. Set each factor equal to 0. Right? I am okay if you go from here to here. We're in honors pre-calculus. I think at that point you can handle the algebra in your head. Okay. I do like you to show work. But at this point, I think this is work that you can include. If you don't include it, it's not a big deal. You can do that in your head. Okay? Now, those of you who have your calculators, okay, I'm going to show you how to actually do this on your calculator. All right? I have this really snooze 50 calculator that I can show you up here. I'm really excited about it. How many of you have your calculator? Okay, how many of you have like the colored version? Like it has the C with it? Okay, everyone turn it on. If you ever want to put a function and to graph it, you're going to hit this y equals button right here. Okay, there's my y equals. If you have colors right here, you have the colored version. If they're not colored, everything still works the same. Okay? So we're going to put in a function. What was our function? It was x times x minus 7? Okay, so here is your x button right here, right next to the alpha, right next to the green button. That's your x button. Here you have parentheses, so you can say times x minus 7, close your parentheses. Okay? Once I have this put in, into y equals, and here's a graph button. If we hit a graph, then it'll graph it for us. Okay. Nice, pretty parabola. Okay. If you have the colored version, I mean, all that's really different is each graph is going to be a different color. It's really not a big deal if you don't have that. Okay. Now, if you want to find a 0, there's a button next to graph that says trace, and above it, it says calc. Okay, so if you press second, and then that trace button, you get to the calculate menu. And what are we going to calculate?
0.
We want to calculate a 0, so you can either arrow down and press enter, or you can just press 2. It doesn't matter. Okay, so then it's going to ask you for a left bound. So I want you to go a little bit to the left of where you think the 0 is. And then right bound, I want you to go a little bit to the right of where you think the 0 is. And then it'll ask for a guess, and so you'll hit enter, and it'll give you that coordinate is 0, 0. Okay, and you can do the same thing over here. So if I want to calculate the other 0, I'd have to move my little cursor all the way over there. Oh, wow. Okay. I'm to the left of my 0, and then I'm to the right of my 0, and so then it'll tell me that my 0 is at 7. Okay? Something that you can use to check your work, but you will not be able to use a calculator to find a 0 yet, because not all of us have a calculator. So just use this as a check. You still need to be able to do this algebraically. Okay? But since some of you have your calculators, I thought I could show you something at least you can do with it. All right? Okay. Okay. Something else you're going to have to be able to do is tell me when a function is increasing or decreasing or constant. When we read in what direction? Left to right. That's how we are going to read our graphs. Okay? So from left to right, I want to determine where this is increasing and where my board is off, where this is decreasing. First of all, is my graph ever constant?
No.
It is not constant, and so we're not going to worry about that. If we had a piece where it was constant, what would it look like? It would be a horizontal piece, right? Okay, so I want you to tell me, let's just assume right now that the graph stops on the edges. Okay, let's just assume we're going from -5 to +5. Okay, so where is the first time we increase? Okay, we start increasing at -3 until, okay, now I like that you are giving me the x values. Okay, we're talking about the domain where we are increasing and decreasing. You're always going to look at the domain. That means the x values. So from -3 to 0, we have a section of the domain where we are increasing. Okay? I put parentheses. Why? Well, it's not a coordinate. We're talking about a piece of the domain. Okay? Why didn't I include the endpoint? No, a bracket means we include that number. Are we increasing at -3? Okay, we're switching directions, aren't we? Okay, so we're not going to include the endpoints because we have a switching directions. It's not increasing or decreasing, we're switching. Okay? Where's the other piece of the domain where we are increasing? Shout it out.
3 to 5.
3 to 5. Okay? And what we're going to do, if we have more than one piece of the domain, here I have two pieces of the domain, we're going to connect them with a U. Okay? It's a weird notation. It means union. We're unioning these two intervals together. Okay? That way I know that they're supposed to all be together. All right? So where are we decreasing? Where's the first piece of our domain?
-5, -3.
-5 to -3. Also, we are decreasing from
0 to -3.
0 to +3. All right? It's always the pieces of the domain. Now, let's assume I want to talk about some infinities here. Let's assume that our graph went on forever. Okay? And let's just assume that it's going to not change any direction. Okay? What would change about this increasing interval? Okay, it would no longer be from -3 to 0. If this went on forever, then we would always be decreasing until we got to 0, correct? Okay, so instead, we would write from -infinity to 0. Okay, because it would always be decreasing. Okay, and if this continued to increase for the rest of eternity, basically, right? Then we would say that it decreases from -5 to -3 and 0 to infinity.
What if it goes 3 infinity instead of 3 to 5 for the second increasing?
Oh, thank you. Yeah. I was getting ahead of myself. Yes, that would be infinity. And then, thank you. This would have to be changed to -infinity, right? I was backwards with my explanations. Okay, so from -infinity until -3, we're decreasing. From 3 until infinity, we're increasing. The reason I wanted to talk about this, infinity, is it a number? No. It's more of a description, okay? No matter what, the infinite, anytime you have infinity, it has to have a parentheses. You can't ever include infinity. Infinity will always have a parentheses. So anytime you're talking about domain and range, okay, your infinities will always have those parentheses. Okay. So here is your homework. All right. I have a note about the vertical line test. That's something that hopefully you remember. What is the vertical line test? What is it?
Like if you took a line and you put it across the graph, none of the dots should ever be on the same vertical line.
Okay, what does it test for?
To make sure that each domain, there's only one domain for range.
And what's that called? You're about to say it. No. There we go. To make sure it is a function. The vertical line test. As long as a vertical line only hits the graph once, anywhere, then it is a function. Okay? That is on page 55. You may need to reference that in your homework. Okay? This is your homework.